So you said this whole thing basically is to make the wheel as round as it can be. How are you able to, I guess, tell when it's done?
So what we're doing is we're aiming. First, we want the wheel to be round, and for that I set specific tolerances.
Okay.
And here we've got 2 dial indicators that you'll be able to see shortly, and they're a very fine measuring tool that can tell me to within a quarter of a human hair's width that the wheel is straight.
Okay.
And what this allows me to do is measure both lateral, side to side, and radial, up and down, all at once. So essentially I get to see the complete health of the wheel.
Okay.
But more than being straight, what's important is that a wheel is correctly tensioned, and evenly tensioned as well. So, as I was saying earlier, it's a Newtonian structure with 2, 3, 4, quarter. I'm going to have to start counting now. It's a Newtonian structure with pre-stressed, pre-tensioned components. And what we're going to be doing is we're going to be putting each spoke to about 125 kilos of force, assuming that the rim you've chosen is suitable for that task. And so that means that a wheel exists under tensioned forces. The math is dodgy, but it's a fun figure. It means that a 32 spoke wheel like this has got almost 3 to 4 tons of force holding the rim together, which is a fun little fact. But yeah, whilst we're trying to make things straight, we're also trying to make sure that all of these spokes end up at as close to the same tension as they possibly can. And there's several ways of doing that. You can do it by feel. A lot of us work by ear, because essentially all they are is a tension piece of wire, much like a guitar string.
Oh, yeah.
3, 4, or a drum head, or anything like that. And what I'll always do at the end is use a tensionometer, and that just gives... A tensionometer is merely a tool that gives a given load, and it applies a given load to the spoke, and you can then use a conversion table to figure out that for a given width of wire and a given load, how much tension that spoke is under.
Alright.
So that's what we're aiming towards. We're aiming towards having a structure that is both true, round, but also evenly tensioned. An even spoke, a wheel could be true, but it could be out of tension balance.